we are creating an artificial cyclone in a small cylindrical like container, and we are going to use the similar one for the producing of a centrifugal effect. Because of the centrifugal effect, you are going to get a separation of the size. Now, till now, whatever we have seen, either it is a sieve analysis or alpine air jet, or it is a shaking screen or a protect screen, you have got one screening or sieve, anything which was present. But this is the equipment which you don't have any size separation medium, like either it is a sieve or a screen, but still you will get a separation. Now you may get the doubt, how can we separate without using the screen or a sieve? We don't get any plus material or minus material. But in this particular case, we are going to get a separation of the size because of the mass. The materials which are having lighter in weight and heavier in weight, and the material which are tend to float and they are having a lighter mass and heavier mass. In this particular case, this is possible only when you have got a cylindrical chamber. First part we are going to see any equipment. This is the tiny diagram which is appearing onto the screen. If anywhere you have got a problem, just you can stop me and ask me the question, no problem. And you are having a construction part. In the construction, the equipment is containing a cylindrical vessel which is having a tapering at the bottom. The first construction of a equipment is, it is having a cylindrical container which is having a tapering at the bottom, and this cylindrical container is equipped with tangential inlet. Tangential inlet means we have drawn in the radiation constant, we are drawing a tangent. Any curve is present, we are drawing a tangent. A tangent is going to touch the circle and not at the right angle. It is in a tangential manner, it is going to touch. Why this tangential inlet? Why it is not at a right angle to the cylindrical container? Because we want to create a cyclone. So the tangential inlet is the second part. The third part is, in the center, it has got a fluid outlet. This is the pipe which is present in the center, which is a fluid outlet. Anytime we are going to have in the pharmaceutical engineering, fluid means either it is a gas or a liquid. Fluids are gases or the liquids. But in this particular equipment in today's class, we are using gases. We are going to separate the solids in the air. That is what this equipment is. So what the fourth part is, it is in the bottom, it has got a solids outlet. So there are four major parts in the construction of the cyclone separator. One is cylindrical vessel with the tapering at the bottom. The second is a tangential inlet and fluid outlet at the center, and in the bottom you have got a solids outlet. These four parts are sufficient to be used in the particular equipment. Now coming to the construction to working part, how it is going to work. It is the tangential inlet is getting connected with a blower or a compressor. When you are forcing the air under the high pressure, the air which is connected to the tangential inlet, it will be entering into the circular cylinder. In the circular cylinder, it will take the cyclone. Cyclone means it will take the world-like movement. In the centrifugal force will be created when it is moving around the surface of a cylinder. That is actually called as the artificial cyclone. This air is containing two types of the particles. One is lighter in weight, and which is having a lighter mass, and another one is heavier in weight, which is having a more heavier mass. So when it is having a tangential inlet entering into the cylindrical chamber, they will be rotated around this particular cylindrical chamber. During that time, centrifugal effect will be created. We know when the centrifugal effect is directly proportional to the mass. Whatever the powder which is having a more mass, they will go to periphery. Whatever the powder which is having very less mass, they will be present in the center. So the centrifugal effect will be more with more mass. That is the reason here the material which are heavy in nature, it will be pushed towards the periphery and they will be coming to the near to the wall of the cylinder. When they are coming collected at the wall of cylinder, they will be going down and collected in the solids outlet. This is one fraction we are separating. And the material is also going to contain a lightweight material. Because of the less mass, they don't experience much centrifugal effect. They tend to float in the air only without getting adhered to the container surface. These will be floating in the air. When the air is approaching to the tapering chamber, that is having a tapering at the bottom, it will tend to take a direction and move in upward direction, because the cylindrical vessel is not continuously cylindrical. At the bottom, it has got a tapering. Because of the tapering, the cyclone will take the diversion and it will be going to enter into the center. There it has got a fluid outlet. So through fluid outlet, the small sized particle will be going out. It means we are getting in the tangential inlet, we are getting a mixture of powder, and we are going to get output, two output of the powder. One is at the fluid outlet, another one is a solid outlet. In the solid outlet, you are going to have a heavier particle, and in the fluid outlet, we are going to get a lighter particles. Now, you may get the question, sir, when the powder is a smaller and it is fine in nature, it is present along with the air, how will you get a powder? We are going to use a filter. That filter, how it is present, you will see in the next within 10 minutes. That will separate your air to solid, and you are going to get a solid output. It means you are getting a two fractions only in the cyclone separator. This equipment is used as a one accessory in your size reduction equipment and many parts. In so many unit operations, other unit operations like evaporation, distillation, where also we are going to use this. At present, at this juncture, if anybody is having a doubt, they unmute yourself and ask me. Otherwise, we will be proceeding with the advantages and disadvantages. That is the second part of our journey. In the advantages of this is not having any sieving surface like a screen or a sieve. That is the reason it won't have any blocks. That is the major advantage. The advantage of this machine is it is not having any sieving surface, and which is not going to have any blockage of the sieves or the screen, because the sieve and screen is not there, but still we are getting a separation of the size. That is actually beauty of this equipment. Without using in CPAT, you will be asked the question. Without using, name the equipment which works for the separation of the powders without using sieve or screen. That means you can write cyclone separator. Where sieve and screen is not there, but you are able to separate into the two fractions. Now, the disadvantage of this particular equipment. The disadvantage is that the output and input, which is one of the output and one input and the one of the outputs, which is present in the fluidized state. The powder is present in the fluidized state. It means if you want to use this particular separator, you need to put the powder in the fluidized state and entering into the tangential inlet. It is one thing, and you are going to get one fraction in the powder in the bottom and another fraction at the top, which is also in the fluidized state. You don't like a top plus material and bottom minus material directly. You are not weighing and getting it. It is present in the fluidized state. Separately, you need to use the filter to separate it. That is actually major disadvantage. It means that if you have got a contamination of the air, that contamination will be entering into your powder also. That is the reason we need to use a pre-filtered clean air in this equipment. Now advantages and disadvantages, sometimes you will be asked applications and limitations. It is applied in the any equipment in the size reduction where you want to separate the material which is in the fluidized state, because the tangential inlet is present in the fluidized state, only air is entering. So if we have got a material not like a mixture is present in the bigger solid bag, it is present in the fluidized state. Later onwards we are going to see in the conveyors where you have got a pneumatic conveyor, where next size reduction chapter you are going to have some of the mills, they will be working like a fluid energy mill. There you are going to have a material in the fluidized state. Then this equipment can be applied, attached to that equipment, so that you need not spend much blower effect to create a tangential fluidized state inlet. Automatically the air is containing a powder, you can separate it by using this. The major limitation of this particular one, the limitation of this equipment is it will separate a powder into 2 fractions only, not like a number of fractions what we have got. We cannot place any sieves here or screens here. You will get one material which is finer and lighter in the weight at the top, another material which is heavier, which is bigger, which is present at the bottom. Only 2 fractions you can separate. That is only the limitation of this particular mill. Okay. Now variations. In the variations of this particular mill, you can vary with the various sizes depending upon your requirement. But the design should be same. You cannot change the tangential inlet to the rectangle or right angle inlet. Otherwise, you will not create a cyclone. You will create turbulence. Turbulence will not create any centrifugal effect. It will cause the disturbances in the powder. It will not separate anything. It will mix the powder, turbulence. You have to create a cyclone. That is the reason tangential inlet design is mandatory. You cannot vary it. But you can vary with the various sizes of this particular equipment. It can be versatilely placed to as an accessory to so many equipment. Now coming to the critical parameters. In the critical parameter of this, you are going to have the inlet air rate, the speed of the air which is entering in the inlet. That is a critical parameter here. If you are pumping very slowly and the air is not having much pressure, then your cyclone will not be created. When the cyclone is not going to get created, all the material will be going up, all the material will come down also without any separation. You need to create a minimum pressure to have the centrifugal effect. That is one thing. So too much of the centrifugal pressure is also not good, because it will cause the blasting. Too much of the application of the pressure, it will not be also good. And you need to see that in this particular equipment, there should not be any blockages which are present that may cause the blast also. Not only that, we are going to have this critical parameter is in this particular equipment is that most of the times when the material is moving, they hit to each other when they are traveling it. If any material is having a sparking effect, so when the material is hitting to each other, they will get a spark. That spark, because when you are hitting one stone with the another stone, you will be getting a spark. That spark is inevitable when you are impacting one material and another. If in your pharmaceutical powder, if you are getting a spark, it may cause the fire accident. That is the reason in our industry, most of the times, this equipment maintenance and engineering, there will be a separate electrical engineers, chemical engineers, mechanical engineers, they will also be working. In the construction, civil engineers will be there. So in the chemical engineering, persons will also be present in our process manufacturing. They will see that they will do earthing of this particular equipment, and they see that material which is having a danger of getting a spark and fire explosion, such material will not be allowed to pass through this. They will use the other approach to separate the powders, because that operation has got hazardous nature. materials which are having an impact that creates the spark. The material is already organic in nature and they are having a dried, and oxygen is plenty is available in the air. So oxygen, fuel, that is organic matter, and the spark, that is fire, is present, it will get a fire accident. Because the fire is produced within the chamber where it is already pressure is there, it will cause the explosion. So such things will be prevented not by B Pharma graduate itself. Some engineers will also be there and they will also be taking care of this particular explosion problem, and they will see and they study the material safety data sheets of the pharmaceutical material, MSDS, they called as a MSDS, material safety data sheets, and they will be studying them and they are going to come out of some solution and resolve the problem. I hope you understand the topic now. Once you are understanding, we will be going to the next topic. Otherwise, if you have got any doubt, now itself you stop and ask me. Okay, then we are going to enter into the second one. Is called as air separator. Air separator is the one which is having a similar one, but there is a modification which is present in this equipment. What you are seeing on the screen is called as an air separator. It is using the air, that is to separate your powder into two fractions. That is actually what we are going to. Previously also air, sir, that is also you can call it as air separator. No, here we are not creating cyclone. There we are creating a cyclone. Now what we are going to have cyclone, without cyclone, how will you separate it? Instead, we are going to create a little bit lower fan-like structure, which is not like a blower or a compressor. We are going to use a fans. That is actually what we are going to have now. First, we will be seeing a construction part. This is also containing a cylindrical container and tapering at the bottom. But in addition to that, it is equipped with a internally one more hopper which is present to collect the center material. That is actually construction part. If you see critically, you are going to have cylindrical container. Eccentrically, it is containing one container in the another. So the bigger container is cylindrical in nature. At the tapering portion, you have got another tapering portion and outlet. This is actually a difference in the construction of previous one and this one. In the center, you have got there one outlet, fluid outlet, but in the center, you have got a rotating disc. And a rotating disc is connected with a rotating blades. They are nothing but wings of your fan-like structures. They are present. So the center is acting as a shaft. The shaft is containing rotating disc attached with the blades. They will be rotated around the shaft by means of a motor, which is present at the top. Okay. Now, we are having a feed inlet previous case in the side. Now we are having in the top. Feed inlet is present in the top now, not in the side. Previously, we have got one outlet at the bottom, another outlet at the top. Now we are going to have both outlets at the bottom only. Now sometimes you will be asked the question in the exam. So in this particular case, sorry, you are having at the feed inlet at the top. Now we will be entering into the working. working portion. Working. In the working of equipment, we are going to feed the material directly a powder mixture at the top in the hopper, which is the sorry. We are going to have feed inlet at the top. The feed inlet, which is present, it will make the powder to yellow to come down. What will happen? Say, for example, I will ask you a small question so that you will understand this particular working of the air separator. Try to understand, apply your common sense only. No need to apply any science or anything, just to apply your common sense. You tell me the question, the answer. Say, for example, you have taken one rice grains and the rice flour. You have mixed both. Rice grains and rice flours are got mixed. You are going to place in your, say for example, in your room, you are going to add that particular mixture at the top of the fan when it is rotating. When you are adding at the top of your rotating fan, the rice grains with the rice flour. Now you tell me, when the fan is rotated, you are allowed to drop the mixture of the rice grains, that means rice pieces, and the powder, which will be falling at the center, which will be falling going at the periphery. Anybody answer it? You have got rice and rice flour. Which will be going to the periphery, which will be
rice flour follow the center, rice grains go to periphery.
Yeah, because wherever they are lighter in nature, it tend to push outside, and they are heavy in nature, it tend to fall at the center because of the mass, because of the gravity. Gravitational force is more when the mass is more, and the material which is having a less gravity, they will be going along with the winds of the air which is created by the fan. It is going to the periphery. That is the reason you are going to have the material is previous case. Why I am asking this question? Don't do the mistake in the exam. Here you are not going to have a centrifugal effect. GPAT question. Air separator is not by the centrifugal effect. It is by the gravitational effect. Whereas cyclone separator is working with a centrifugal effect, where your heavy material is coming to the periphery, lighter material is present in the center. In this particular equipment, your heavy material will fall directly into the center, and the lighter material is going to the periphery, because the here principal working here is a gravitational force, not a centrifugal force. If anybody is having a doubt, now itself you ask, because based on this you will have a GPAT question based on your sessional, and you are going to write a working of both equipments and compare and contrast. There is another question you are going to be asked in the exam. Compare and contrast cyclone separator and air separator. That is the reason you need to have a clarity now itself. Now, in this particular case, in the similar manner what you have predicted, when you feed the material at the top, the material which is heavy in nature, they fall directly and descend down, and it is falling in the center receiver. The center receiver is present in the inside the cylindrical chamber at the tapering. So you will get one fraction of heavy material this side. This arrow mark is showing this side. Now, the lighter material, it is pushed by the air wing. The air currents are circularly rotating because of that reason, because of the light weight, they will be pushed towards the wall, and they will be collected, and they will be collected at the center. You are seeing the fine outlets which are present at the center, that is collected from the periphery. Periphery means near to the container. It means the material which is coming to the walls, it will be descended down and collected in this outlet, and the heavy material directly fall without any floating, and they will be collected in this. It means in this case also we are getting fractions which are separating into two, mixture of powder separating into two two powders. This is the working part of it. In the construction we have seen, it is containing a cylindrical vessel with the tapering at the bottom, and inside it is containing another hopper to receive the heavier particle. In the center it has got shaft. Shaft is rotated with a motor, and it is connected to a rotating disc. So they have got a blades. When the blades are getting moved, when the the feeding hopper is present at the top. In the working, when the feed is placed inside the inlet, when it is going slowly, the heavy material will fall down directly and received in the center receiving hopper. And the material which is lighter in weight, it will be pushed by the air currents to the periphery, collected at the surface of your container, of the vessel, of the equipment. You are going to receive as a fine particle in the bottom. So the two fractions, which is one is heavy and another one is a lighter, it will be collected without using any sieving surface, either screen or sieve. You are not using, because previously we have already seen in the Rotex screens or anything distortions and pharmacopoeial specifications, and you need to purchase them, and we need to follow the standards of the sieves. If it is failed, we cannot sell our product. Without using sieve surface and without any distortion, nothing, it will not be without using the sieving surfaces also we are able to get the size separation done. That is actually the beauty of this equipment also. Coming to the advantages and disadvantages. The advantage of this mill the advantage of this mill is not like your Cyclone separator. It does not require anything in the fluidized state. Just like simply powder mixture you can put in the hopper. Hopper is like a funnel-like structure. We call it is a funnel in the small lab. When it is present in the bigger equipment, we call it as a hopper, because it is taking the feed material, tons of material, and it is allowing in a smooth manner in a particular path. That is called as a hopper. The feed inlet hopper which is present, that will receive the solid mixture directly. Not like a Cyclone separator, it is present in the fluid state. That is bigger advantage in this. And you are going to get the output without using any sieving surface, like a sieve or the screen. So it is good that you don't have any blockages. That is another advantage. The disadvantage in this particular case of air separator, if you critically see it, the material may be hitting onto the discs and the blades. The material which is solid in nature, it may be hitting onto the edges of the discs and the blades. They may get reduced. Size reduced may be there, may be getting reduced. It means some of the grains may be getting broken when they are falling and hitting onto the blades and the discs which is present in the shaft. This is actually disadvantage. What is our unit operation? Our unit operation is to separate the size, not to reduce the size. But it is reducing the size. That is one disadvantage. Application of it. It is applicable to separate any two powders which are having heavy and lighter in nature. We want to separate without using any sieve and sunscreen. We can apply this air separation. We can apply. And the limitation of this particular one, what is the limitation? Limitation, again, it will get only two fractions, not more than two fractions. And this is only the disadvantage also. You don't get more than two fractions. One is heavier, another is lighter. One heavy one is present at the center, lighter one is present at the periphery. Variations of it. Variations, you can vary number of wings and rotating discs which is containing number of blades. Say if you have got a 2-blade fans also, 3-blade fans also, 4-blade fans also. So in this particular case, we are going to use a variation of depending upon number of wings we can create and make it to get that one. And what are the critical parameters? The critical parameter in this particular case is The speed of the rotating disc is the critical. You should not make it too fast and too slow. Too fast and too slow. If you don't put on the rotating disc, the entire material will fall down at the center only without any separation. If you don't switch on the disc, if it is not rotated, the entire material will fall, whether it is a powder or anything. After falling, little bit may be getting dusted and it is going to the periphery, but you won't get separation. That is the reason. Nil speed is not correct. Highest speed is also not correct. Even if there is highest speed, it will push your rice grains also towards periphery. That much highest speed is not good. So the speed of the rotating disc is critical parameter here. And the feed inlet, you are putting all 100 kilo at once. Your wings may get distorted and your material may not be getting separated. That is the reason you need to feed in a particular rate, 1 kg per minute or 1 kg per 10 minutes, like that. You need to slowly feed the material so that smoothly you will get a fine powder and heavy powder portions separated. This is the critical parameter. So now we have seen, you will be expected to get the questions in the GPAC. Right? Name any two equipment which are separating the powders without using screening surfaces or the sieving surfaces. One is Cyclone separator, another one is air separator. In any combination which is being given, and these two required to be present, or what type of question you need to remember and ask, because these are the versatile equipment. Without using sieves and screen, we are separating it. Sometimes in the examination of a sessional and your term end, you will be asked to compare and contrast. Comparison between both have got a cylindrical chambers. Both will get a 2 portions as output. Only 2 portions as a output. But the differences in the previous one, what is the difference? You are having a tangential inlet. Here you have got a central inlet. Where you have got a side inlet. Here it is in the top inlet. In the previous, you have got one outlet at the bottom, one outlet at the top. Now both the outlets are at the bottom, and you don't have rotating disc in the Cyclone separator. You don't have compressor here in the air separator. Their compressor or blower is required. So these are all the differences you can write. So by understanding one concept, you can answer any type of question, even though it is not present in your book, and you can recapitulate and you can answer it. I hope you understand these two very, very important concepts, which will be generally used later as a one part or accessory later. At this juncture, if anybody is having a doubt, you can ask me. Otherwise, we will proceed to the next topic. This is called as a bag filter. What is this bag filter and how it is being used? This is generally used in most of the cases at the fluid outlet, which is present in the Cyclone separator, which is connected to this cyclone bag filter. Most of the times, if you see here, there are two diagrams are present. One I am explaining now, extreme left. Another one is right. In the left, if you are putting the cursor here, the hopper inlet to feed the powder. It means this we are getting from the Cyclone separator. Say, for example, you have got an outlet which is already present in the fluid outlet. This pipe will be connected to the bag filter here, where this is the base, hopper inlet to the feed. This is actually a feed to the bag filter. The name itself, it is containing a bag filter, means the filter is present in form of a bag. There is a bag here. If you see here in the center, this is the bag. This is actually the bag. So these bags are present just like your pillow covers, which are present, or your cylindrical blowsters, which you have got. Like that, it will be stitched with the filter material. So that is actually what the screening surface here is, the cloth. Cloth is containing a cotton or a nylon or a Teflon or any wire or cloth thread. The thread is crisscrossed to get a cloth. That cloth has got a aperture size of the opening in the between the gaps. That gap is lesser than the size of your powder. That is the reason these cloth bags, which will be used, stick to the bags, and it will be placed here. First, we will be seeing the bag filter construction. The bag filter is containing a metallic casing. That metallic casing inside it is containing a filter bags in it. And in the side it has got a hopper inlet, and in the bottom you have got a discharge, and it has got a valve in it. At the top it has got a cam arrangement to allow the air go out, or you stop allowing the go out. So it is actually a cam. It will make the material, air is going to go out or air is going to enter in. That is actually two things which are present. You can allow the air to go out or from external air to go in. Both the case you can do it. That is actually this cam arrangement. The damper, which will be making closing and just like acting as a gate here. Now we are going to see the construction part. Construction part is having two things. One is filtering period, another one is shaking period, A and B. In the working part, we are going to have a shaking, filtering period and shaking period. What is filtering period and what is shaking period? The first phase of your separation is filtering. The second is shaking. Now, we will see the working of it. In the working, first we will be entering into the filtering phase. In the filtering phase, the hopper inlet, it will receive the material which is containing air and solids. They are going to enter into the bags. You know that bag has got aperture size which is smaller than your powder. So powder will be blocked or present inside the bag, and air is ready to go out. This arrow marks, it will be showing the air is going out. In this particular case, you see the cam arrangement in such a way that the damper has got opening, allowing the air to go out to the discharge manifold. It is air is going to go out, and your powder is getting accumulated here. Your powder is getting accumulated. After a particular period of the time, this entire bag is got blocked with the powder. If you are pumping further, then what will happen? Your bag will burst as a balloon, and it will burst and get leaked. When it is getting leaked, your material will be both the air and your solid will be going out to the discharge manifold. That is the reason at a particular period of the time when your bag is filled, or your bag is filled with the powder, or your bag got clogged, at that time you need to start your shaking period. That is called as a B. In the working, we are going to the next phase, that is called as a shaking phase. In the shaking phase, what will happen? You will be allowing air from the outside. This cam is opening and dampener is closing this, and the air is allowed to pass from the top through the bag. Previously, what is happening? Internally through the bag, the air is going out and moving forward. Now, air is moving from the top and entering into the bag, and it is coming bottom. Previously, air movement is bottom to top. Now, air movement is top to bottom. Previously, the air is present inside the bag and going out. Now, from the outside environment, the air outside the filter bag, it is going to entering into the filter bag and going down. This is actually called the shaking period. In the shaking period, what will happen? The air pushes the blocks which are present in the bags, and it will allow the powder to come down. And in this particular case, if you see in the bottom, the discharge valve is opened. Previously, it is closed, and nothing will go to the bottom output. Discharge manifold is closed. So in the shaking period, it is opened. You will open the valve here, and the powder will fall down. All the powder which is accumulated in the bag, it will be falling down. Once it is falling down, and the bag will be having a clearing of all its apertures, because air is forcing in the reverse direction. So we are getting opening of all your apertures. All pores are getting opened. Once they are opened, again this filter bag is ready for the filtration operation. At that time, what do? You stop the discharge manifold at the bottom, and inlet, then you are entering into the upper inlet and making your cam and their dampener arrangement in such a way that the air is allowed to go out smoothly, and you are going to get a filtered clean air which is coming out. Once this particular operation, again the filter bag is filled, and when your filter bag is filled means again you need to stop at shaking period. You are taking this valve closed and you are opening the dampering air closed, and you are opening the air, and air is entering and pushing the powder down again. Like that, you are going to create a process. You are removing the block and you are allowing the stopping the process, allowing the removal of the material, and again you are making the filter bag ready for the next filtration period. The cyclical movement which you are causing interruptions, and you are interrupting it, and you are stopping after particular period of the batch is over, and you are going to take. Now you tell me, if you want to classify your filtration equipment, continuous and the batch process we want to classify, because the 2 marks question you will be asked the question separation, size separation define, and you classify it. Size separation, we know the size separation is a unit operation which removes the powders into 2 or more fractions, mixture of powders into 2 or more fractions by using the screening surface or screening medium. So in the screening surface, in this particular one which we are going to have is a bag. This is what type of equipment. This is a batch, because after particular batch of the size is over and the complete your bag is filled, you are going to stop the operation of the filtration and you are going to entering into the discharge. Whereas your cyclone separator and air separator, but they are continuous operations. It means you can feed your material continuously and get your output continuously. They are continuous equipment. Whereas this bag filter is batch filter. Batch, it means one batch of some lot you can put till your filter bag is filled. Till the time only you can use the filtration. That is size separation. Beyond that you can't do it, because entire bag is filled with the powder. No, nothing else will enter. So you need to stop. No other option. It means it is not continuous. Again you need to remove it. Again you make the filter bag ready, and then you need to start a shaking period and filter period. Like that you need to repeat it every time. You need to stop it. That is actually called as a batch process. Now, advantages and the disadvantages. The advantage of this particular mill is that you are going to separate the powder which is present in the air in the fluidized state. That is the major advantage of the bag filter. And the disadvantage of the bag filter is sometimes you will get a fibers of your cloth as a contamination. You are stitching the bags with some cloth. That cloth will act as a contaminant. That fibers of the cloth which will be present acting as a contamination in our powder, it will be entering it. That is the reason fiberless cloths. Generally, if you see nylon, silk, they will not be having much fibers when compared to cotton. Cotton fibers, too much is the problem. So that contamination of the fibers is the one problem. Where is the applications of it? That is another one you are going to have. Application of this one is to remove the hazardous dust in the laboratory. You can pass all your air to the exhaust fan. You are having in your laboratory exhaust fan, you attach your bag filter near to the exhaust fan, and you will not allow your extreme fumes or the powders which is present in the lab to go out. Otherwise, your flora and fauna will be getting affected. So, at the discharge end of your factory, wherever the pollution of the air is present, we are going to place this bag filter to remove all the hazardous air waste, which is containing as a dust. That you can do it. It is major application. It is also applicable in along with cyclone separator to remove the particles from the air which is in the fluidized state, the particles which are present. So that is another application. So most of the times which will be used in the pollution control, in the air pollution control, and in your pharmaceutical industry, where to separate the powder which is present in the fluidized state where you are applying it. The limitation of this particular mill. The limitation of the mill in this particular case is you are going to have the material which is present in the fluidized state as an inlet. You are not going to separate as a powder and you are not going to separate it. You are going to separate the powder which is present in the fluidized state. That is only the limitation. Directly to mixture of powder, you take it and pass through that, you won't get. All powder will be blocked and you will be getting it. But you can separate only solids from the air. That is actually the limitation of it. Variations of it. You can create n number of bags depending upon your output requirement. And diameter of the bag, another variation. Bigger diameter and small diameter bags, you can make it and optimize it. These variations of the bag, length and the diameter of the container and the number of bags, these are all the variations we can use. Critical parameters. The critical parameter in this case is inlet feed. Feed should not be too high in such a way that you are, just like a ballooning effect, you are breaking your bags. It should not be too high. At the same time, it should not be too low also. There is a input parameter which is having optimum pressure, so that the bag will withstand without any leakage. What will happen if any leakage or hole is present in the bag? Immediately all material which is present in the air will be entering into the output, that is in the air itself, and you are not going to get any separation and you are losing your material. That is actually a major problem. I hope you understand the bag filter concept also. Now with this background, we will be entering into the next class, size reduction. Size reduction means we have got a bigger powders making into a smaller. That is actually called as a reduction in reducing the size.